Alright, so to run the setup, the first thing we need to do is click on File and click on New Project. So let's call our project, say, trial. Okay, so I am storing it in a folder called Simufact job. Then I click Apply and then OK. Now the process type will change that to resistance spot welding. Temperature in Celsius, leave it at 20. Because we want to weld two plates together, we will need two components, and because we are dealing with we'll have two fixings that we are going to use for welding the two plates, and then we are going to use the C-spot gun as the robot that will perform the welding process. So I click Apply and OK. Now on my right hand side here on the object catalog, I have geometry, I have material, I have temperature, which is already set to 20. So the first thing I need to do is to right click on geometry and go to library. From the library, I double click on tutorial, and I will be picking lower plate and upper plate. I say OK because we're trying to weld two plates together. We use units, just click use units for all meshes and click on OK. So we see here the lower plate has been uploaded here, the upper plate has also been uploaded. So just simply drag, hold the left click on the mouse and just drag and drop on the first component. So the first component is the upper plate, then drag and drop on the second component, which is the lower plate. Automatically from the view here we see that they have been merged together. But we will be doing more than just merging them together. We need to slide the plates such that they are sitting completely on top of each other. So right click on the lower plate and then choose object manipulation and choose translational. So what we are trying to do is we are trying to move the object along this axis, and that axis, you just take note of the display here. When I touch this, it shows that that's the x-axis. If I touch this, it shows that's the x-axis, and if I touch this, that's the z-axis. If I touch this, that's the x-axis. If I touch this, that's so I want to move along the y-axis, but automatically my direction is to the right, so I want my y to move in the opposite direction. So I change that to -1. So instead of moving this way, it's moving backwards. Step size, let's change that to mm, and let's give this like 2 mm movement. So for every move we press, the plate will move by 2 mm. So let's continue to move that till we are directly underneath the other plate. As you can see, we are fully underneath the other plate, so close that and we are done with that. The next thing we need to go is material, so we right click once again and click on library. Now that we are in material, we need to choose the material that we're working on. For the first experiment, the material we are using is low carbon steel. So the first thing you need to do is to clear all filter, go to general steel and choose low carbon steel. Well, how do we know low carbon steel? Low carbon steel is represented by the IC number 1311. So let's come to this. Is, as you can see here, these are the IC regions. So just scroll down to get to IC 1311. Okay, we are now in IC 1311 and we have two values. This is the one we are going to use. The reason being that the DIN number is 1.0, so let's use this. And because the minimum temperature here is 20, since we are working with 20 degrees Celsius as our ambient temperature. So just click on that, and then you scroll to the bottom here and just click on OK. Then you can right click and just rename that to low carbon steel. Once again, we have to import the next material. So the next material we're working with is high strength low alloy steel. So once again, clear out the filter. Now we'll go to general steel. High strength low alloy steel is IC number 5115. So we'll come to the IC region again and we check for IC number 5115. Okay, so these are all IC 5115. But which one are we going to use? Now the underscore H here represents hot working, underscore U here represents universal, then this also is universal, but underscore SW represents spot welding, and we are carrying out spot welding, so we select that as our material and then click on OK. Right click and then you rename it as high strength low alloy steel. Now the upper plate is low carbon steel, so just drag this and place it on the upper plate. The lower plate is high strength low alloy, so drag it and drop on the lower plate. Now you see that the lower plate is no longer red, so we are done with the configurations for both the upper plate and the lower plate. The next thing we need to do is to generate the fixings that will hold the plates in place while we are welding. So we right click and then we click on generate geometry. Now the geometry has been generated, so the first thing we need to do is change the slice to 2, slice on y-axis to 40, and the slice on the z-axis to 40. The next thing is we go to details. We set dx as 0, direction of the x-axis as 0, direction of the y-axis as 0, and direction of the z-axis as 0. Then we'll change this to mm, everything to mm, or even these two we change to mm. Now after changing it to mm, we then need to position the plate at the exact region where we want it to be. So let's see, as we make changes here, let's see what happens. First, set your x to 0. Okay, so when we set our x to 0, what do we notice? We see that the fixing is sitting just directly at the edge of the other plate, so that's fine. The next thing we need to do now is to adjust the width, the height, and the depth. So we are going to be using a width of 2 meters, which is 0.00, sorry, 2 meters, 20 mm, 2 mm width, height 20. Oh, sorry, I did that in a hurry. I entered too early. So once again, I click on generate, change the slice of x to 2, slice of y to 40, slice of z to 40. Next, you go to details, change your dx to 0, dy to 0, this mm, this mm, this mm. Set your x position to 0, change this to mm, everything to mm. Okay, so our width, we'll put that as 2, height 20, then our depth would also be 2. Okay, so now we see that from what we have here, our fixing is entering inside the plate, so we need to do object translation to move it, or we can move, so we need to adjust the position here. So for our z-axis, let's set that to 10. So we see that it has moved too high, so let's try to adjust the Z. So let's set it as 5. 5 is still too high. 3 is also still too high. You see it is still floating. 2 is entering, so it means 2 is too much. So let's say 3.2 too high, 2.8 too high, 2.2. Excellent. So we set that 2.2, we see that 2.2, and it is sitting perfectly on top of that. Okay, so we want to adjust it to this, to move from this side to this side. So let's change this to -15, and let's see what happens. See, it moves that way. So let's change to -22. Not enough. -40. Excellent. So we've been able to adjust the fixing to the position where we want it to be. So the next thing we need to do, check your primitive once again and then click on OK. Next thing after doing that is you right click on your fixing here and click on configure. When you click on configure, we see that we have fixing and everything is all set, so you don't need to touch anything there. Just click on OK. The next thing is go to fixing 2 and we try to generate geometry. So generating geometry for our fix 2, once again our slice is 2, our slice for y-axis is 40, our slice for z-axis is also 40. Then we'll go to details. Remember to set all the directions to 0. Then we change all these to mm. This is also mm. Remember what the width was, 2, height 20, then our depth was also 2. The next thing is the direction, so we set our x to 0. So after setting our x to 0, remember this was -40, so let's put it at 40. And let's see, 40 is too much, so let's put it at 30. 30 is still too much. Okay, so let's give it 4. 4 is also still too much. Let's call it 3. 3 is much. 2. Okay, let's say 1. Okay, I think 1, we are good at that position. Still, if we want to bring it in a bit, so let's give it like a 0.5. Okay, so I think we are good there. Let's do 0. Okay, so I think 0, yes, also looking good. Now our z, we need to move it up a bit. Remember what we set? We set it at 2.2, I think. Yes, it was 2.2 we used, and 2.2 is sitting perfectly where we want it to be. So we click on OK, and we are done with the second fixing. Next thing we need to work on is our 6-pot gun. But for us to move to our 6-pot gun, we need to be able to set the trajectory of where we want the welding to take place. Okay, so to set the trajectory of the welding, just come to the trajectory, right click and click on new point sequence. Click on the plus sign. The plus sign will automatically generate a new point sequence. Change this to mm and click on local vector. Click on yes. Okay, so our x-axis will remain, our x-axis remains 0. Now let's see what happens if we set our y-axis to 4 and our z-axis to 2.2. Let's apply that and see. Then take this, tell this to be 0, let this be 1, let this also be 1. Okay, our directional, our point is not showing anywhere. Okay, so let's go back and configure it properly. Again, we make this mm. Okay, so let's give this 0, and let's see what happens this time. Okay. Okay, so the trajectory, let's go once again. Let's change this to mm, then change this to local vector, then click on the plus sign to start. Leave the x as 0. For our y, let's say minus 2.2 as an example. Z, let's say 1.2. Okay, now the z, leave it as 1. The x also leave it as 1. Apply and press OK. We can't see anything here, so in order to make that possible, what we need to do is drag and drop that into your C-spot gun. Okay, so dragging into our C-spot gun, we are able to see the direction of the weld, so we are going to fix that now. So configure that. We change this to 0, then we apply to see what happens. Okay, so we see that the weld direction is now straight, but we don't want it, we want it to be in the opposite direction, so we change this to -1. Okay, so when we click apply, it has turned upside down, so we need to adjust this such that it comes towards the center. So okay, let me change this to mm. Okay, so how do we move that? So we change this to about 0.5. It's not in the center yet. Okay, so let's say this is 2. Let's see where it moves to. It's not enough, so let's give this like a 20, and let's see what happens. Too much, so let's give it like a 10. Okay, so it seems to be in the center, but we need to move this along the y-axis backwards, so let's give this like a -10. Let's see what happens, or a -22. Let's see what happens. Okay, so it's almost in the center, and I think we are good at this point. Okay, so you see, we seem to be at the center. We can carry out our weld here. Everything is looking very perfect now. That's good. Now we see that our sports gun is still shaded, so what we need to do is we right click and click on configure. Okay, now in configuring our sports gun, we have this. So just before we change anything here, come to welding parameters and we'll come to new resistance port welding parameters. We leave the general properties like that. Now we'll come to electrical properties, clamp force table, we edit. You click the plus twice. So I want the simulation to run for about 0 to 0.25 seconds, and I want the clamping force to be about 4,500 Newton, which is 4.5 kilonewton. Click apply and OK. Next thing I need to do is to fix the electrical current that I will be using. So I need up to 5 points. So at 0 seconds, and let's say at 0.03, I'll be using 0. Then at 0.05 to about 0. Let's say 0.22. Change this to kiloampere. I want to use 4 kiloamperes. Then okay, so I can delete this. I don't need this too much, and I make this 0.25. Always ensure that the last time that you have corresponds to the one that you have in the previous. So this is what this is the way the current will be passed. So when the welding starts at 0 seconds, no electrical current is applied. At 0.03, no electrical current is also applied. The reason why we have this is because we want to get this step function. Electricity is not a ramp. The electrical current has to be applied as a step function and not as a ramp. So that's why we need to have this variation between 0.03 and 0.05. And also when we are cooling or when we are done welding, we need, while taking out the electricity, it also needs to close as a ramp. So we apply and then we click OK. close as a step function rather than as a ramp. So we click OK. Now we drag these welding parameters to our spot gun tool, the one we just created, to our spot gun. The next thing we do now, we right click and then we configure the spot gun. Now you see that it says end weld, welding time, end time. So now we have time in our welding. So we come to weld gun. We choose our weld gun. We choose F01628 and then also F029. Okay, so our weld gun have been applied. Initial approaching, let's change this to mm. The initial approaching distance, let's leave it as 5. The initial approaching weld gun opening distance, let's leave it as 5. Let's apply that and let's see what happens. Okay, so we see that okay, so let's do this and see if the welding is running properly. Okay, so from what you see now, if I click this, the distance you see here is the initial welding distance between the electrodes. Once again, at this point the welding has begun. Thereafter the welding ends, and then the electrode has completed their job. So we take this back. So okay, so I think at this point we are fine. Now the C-spot weld has also is no longer checking red, which shows it's valid. Now we'll go to our solver and we configure. Now when we go to our solver, we select stress tensor. We don't use phase transformation because the material we are using does not require phase transformation. We click on parallelization, choose number of core, change that to 4. Then we apply that. Come to time control, we click the analysis time and change this to 10 seconds. Welding time 5 seconds, cooling time 5 seconds. Apply. Come to refinement and click refinement level of 1. Leave this as, we change this to 3, and then we click apply. We come to this point here, we change this to mm and also change this to mm. This we write as 0.001 and this also we write as 0.001. Click apply and then we click OK. At this point you see that the solver tool is no longer red. So the next thing we need to do now is to click on run. We save and then we allow the analysis to restart. We click on start analysis and then the analysis has begun. And then although the analysis may take some time to run, so give it enough time to run. Yeah, basically that's just everything that needs to be done in order for you to be able to use the Simufact welding to carry out the welding simulation. So I will pause the video at this point and then come back when the simulation is done to explain how we generate other results.